Today's lesson is lesson 11-2 regarding arcs and chords of circles. This is another lesson that is very definition, theorem, and postulate heavy, so I'm going to focus on the definition, theorems, and postulates because if you understand them, then you can apply them to any problem situation. The first thing that we need to talk about, and that's really kind of the core of today's lesson, is understanding what a central angle is. A central angle is an angle whose vertex is at the center of a circle. So as I look down here, angle ABC is our central angle. And an arc is an unbroken part of the circle consisting of 2 points called the endpoints and all of the points on the circle in between. So in this case, the arc formed by the central angle would be arc AC, and we'll talk about how we name arcs in a minute. There are a couple of types of arcs. The first type is a minor arc. A minor arc is an arc whose points are on the interior of the central angle, and the measure of a minor arc is equal to the measure of that central angle. So if angle X was, let's say, 23 degrees, then the measure of the arc would also be 23 degrees. Next, we'll go to a major arc. And a major arc, I always like to think of a major arc as going the long way around, and I'll show you what I mean in a minute. So to find the measure of the major arc, you take 360 degrees and you subtract out the central angle. So this is what I mean by going the long way around. I would travel in the exterior of that central angle. So it is a larger angle. It's almost, it's similar to an acute angle versus an obtuse angle, if we were talking about angles. And then the last one, there is one special type of arc that is neither minor nor major, and that's a semicircle. That's if the arc travels from one endpoint of a diameter to the other endpoint of a diameter. And right here we have a semicircle, and that semicircle is always going to have an angle measure of 180 degrees. So then the matter of naming angles is important. Matter of naming arcs is important here. If you are naming a minor arc, you're going to use 2 points. If you're naming a major arc, you're going to use 3 points. So if we look at the first example here, arc AC is a minor arc. Arc ADC is a major arc. We have to use that third angle to indicate that you're going the long way around. And you also need, you have to use the third point, to show that you're going the long way around. You'd have to use a third point for a semicircle as well. Otherwise, people may think that you were just talking about the diameter instead. Okay, moving on. This is pretty self-explanatory. Adjacent angles, I keep saying angles. Adjacent arcs are arcs on the same circle that intersect at exactly 1 point. So you can see that these two arcs, arc RS and arc ST, intersect at that shared point, point S, and that makes RS and ST adjacent arcs. Calculating the measure of adjacent arcs would just simply be to add the two arcs together. And that's called the arc addition postulate right here. Moving our way through, we have congruent arcs. Within a circle or congruent circles, congruent arcs are two arcs that have the same measure. So if we look over here, we know that these arcs have the same measure because they have the same central angle. So looking here, both of those have a central angle of x degrees, making these two arcs, arc ST, congruent to arc UV. And that's congruent arcs. Moving on to theorem 11-2-2. I always think of this theorem as there are three pieces of information, and if you know one piece of information, if you're given one piece of information, then you can figure out the other two pieces of information. And that information is as followed: the chord lengths, the arc lengths, and the measure of the central angles. So we'll talk about this. In part one, it says congruent central angles have congruent chords. If my central angles are congruent, then that means that chord ED is congruent to chord BC. Part two, congruent chords have congruent arcs. So in this case, if chord ED is congruent to chord CB, then arc ED is also congruent to arc BC. And finally, congruent arcs have congruent central angles. So if I had congruent arcs, which I do here, arc ED is congruent to arc CB, that makes the two central angles forming those arcs also congruent. So angle EAD and CAB are congruent. And finally, the last two theorems. The first one is 11-2-3. In a circle, if a radius or diameter is perpendicular to a chord, then it bisects the chord and its arc. So if I'm looking at the chord EF, the chord EF is bisected by the radius CD. If I'm looking at arc EF, minor arc EF, it is also bisected by the radius CD. So we could say that arc ED is congruent to arc DF. Okay, and similarly in theorem 11-2-4, in a circle, the perpendicular bisector of a chord is the radius. So if a chord is bisected, it is always going to be true that is either a radius or a diameter, because the only way that you can bisect that is if you're going through the middle of the circle, the center of the circle, right? So the only thing that can go through the center of the circle A is either the radius, which in this case would be AK, or if it goes all the way through, as in a chord, it would be chord JK, which is also known as the diameter JK. Those are all of the theorems and the definitions that you'll need for today's lesson. Please refer to them often when making calculations and solving problems relating to arcs and chords. And that concludes today's lesson. Thank you.